All right, so we're about to start a big chapter on matrices, but today, what I like to do in the past is introduce something that tends to show up at math tournaments all the time. And I realize that there's a slim to no chance that we will actually go to other schools to take math tests this year, unless things get vastly better in a shockingly and alarmingly quick rate. We might have the state test, because they've already talked to me about possibly doing an online deal where we host our students like out in the pod or something. And we may figure that out. But regardless, the way I formatted the class has always been this way, and I didn't want to redesign all my tests and everything. So we're kind of jumping to something today that shows up a ton at these math tournaments. It's a simple concept if you memorize well or understand well and can kind of process. But it is something that a lot of people miss because they don't really get it and they don't ask good questions. So make sure you ask good questions. If you're at home, make sure you send me some questions and I can maybe detail it out better. But what we're going to look at today and tomorrow is something called binomial expansion. Okay? And some of this you may remember from Tyree's class because I believe she worked on it a little bit. And I'm not, oh, by the way, I'm not going to go over your test today, probably, unless we can get all through with this today. I'm probably going to go over it Monday when we get back, just because I still have all the virtual stuff to go through and a few other ones. But if we have time, we'll take a look at it. Okay, so to start out today, I want to talk about binomial expansion. All right. So everybody know what a binomial is? It's just two things added or subtracted together. Could be anything, could be 5x squared minus 7x, could be x squared minus 5y squared, could be a plus b. I'm going to start very basic and very generic and say a plus b. That is a binomial. Now, expansion basically just means how can you take a number raised to a power and simplify it, or expand it out into its longest. This would be like if I write a plus b squared, that's like the factored version of it. To expand it means to have it all multiplied out. Now, we all know that if I raise something to the 0 power, what do I get? 1. I can just write 1 right here. We know that if I raise something to the first power, I get what? Just a plus b. And I'm going to write 1a plus 1b. And we probably know, although a couple of you made careless errors on this, that if I raise something to the second power, that a shortcut would be to square the first term, which gives me a squared, or 1a squared, to multiply the a and the b together, and then to double it. That gives me 2ab. And then to finish off by squaring the last term, which gives me 1b squared. Now, I would normally not write the ones in there, but I'm trying to show you something. And some of you may already be seeing it, but
oh, is it?
okay? Just hold that thought for a second.
Uh-oh.
All right, now, I doubt that many of you know how to cube this binomial off the top of your head, but my goal is that you will be able to do it quickly by the end of today based on what we're going to learn. But really, if you didn't have this little property I'm about to show you, or this triangle, okay, that Pascal came up with, you would have to write this out 3 times, and then maybe distribute or FOIL a couple of them together, and then maybe multiply the other one in. But you would end up with this when all was said and done. You would end up with 1a cubed plus 3a squared b plus 3ab squared, and then you'd finish up with a 1b cubed, or just a b cubed. Now, I've already said it, some of you have already seen it, but what is this thing right here?
Pascal's triangle.
It's Pascal's triangle, and if when you look, or Pascal, however you say it, if you look at this, and I'm just going to kind of go through the numbers, if you look at the numbers, the 1, 1, 1, the 1, 2, 1, and the 1, 3, 3, 1, there is a system by which you can look at the numbers in the row above to determine the numbers in the row below it. So if I wanted to know what a plus b to the fourth was, and I didn't want to take the a plus b squared and multiply it by itself, which is really a tedious 9-step process, just to multiply it out, not to mention combined terms. I could go straight to my row by doing what?
1, 4, 4, 4.
So the first term would be a 1, the next term would be a 4, and I'm ignoring the variables for now. The next one would be a 6, and then a 4, and then a 1. And if you see what I've been doing here, I'm basically adding the term to the diagonal right and left. There's diagonal right, there is nothing to the left, so just 1. Here, that and that, 4. That and that, 6. That and that, 4. And that and nothing, 1. And you can see that pattern throughout this process, right? Now, what about the variables? What have you noticed about these variables?
The A goes down, the B goes up.
The A goes down, the B goes up in power. So if the A is the one on the left, then whatever is there is being raised to the third, and it's going to go third, squared, 1, and then nothing. And what's A to the 0? Y'all remember that? What's any non-zero number raised to the 0?
1.
Yeah, it's always 1. Now 0 to the 0 is undefined. I don't know if you knew that, but so you can't say everything to the 0 is 1, but every number that's not 0 raised to the 0 is 1. So I don't bother writing A to the 0 in there, but the A to the 0 makes sense, right? 3, 2, 1, 0. And then the B, the second term, whatever it is, remember, it might not just be a B, it could be a 6x squared or anything random. That starts on the right and goes b cubed, b squared, b to the first, no b, or you could say no b, 1b, 2b, 3b. So what do I have here on the fourth? I start with a to the fourth with no b, a to the third with 1b, a squared with b squared, and then a to the 1 with b cubed, and then finally b to the fourth. And this rule, if it's plus, it's always plus. Which kind of makes sense because there's no negative even in play here if you were to write that out and FOIL it all out. You track with me? So hopefully this will help you. Now granted, if I say, hey, what's a plus b to the 12th? Well, this gets a little bit painful because to determine the 12th row of this thing, what do you have to do? You got to know the 11th. And to know the 11th, you got to know the 10th. To know the 10th, you got to know the 9th. So this would be really tedious. I will not ask you to do that. Usually on my test, I ask you to expand one of these, and I normally ask it at like something to the fourth or the third. I might ask you to write out Pascal's triangle out a few rows, just to make sure that you know what you're doing. But you'll see as we get through this day and tomorrow that there is a way to get certain terms. What a lot of times in a math tournament, they'll give you a binomial that'll look much uglier than that, but to the 12th. And they'll say, hey, what's the 7th term in the expansion? And there's a way to jump straight to the 7th term, a little binomial expansional formula that gives you just that term and without having to do the whole triangle. And that's what we're going to today. So one more row, just to make sure you're with me. If I had a plus b to the 5th, what are we going to do? 1. I'm going to do the numbers first. 1, 5, 10, 10, 5, 1, and then A5, A4B, A3B2, A2B3, AB4, B to the 5th, and all positives for the positives. Not too bad? Okay, now what we need to be able to do is take this generic formula and apply it to when we don't just have AB or XY. What happens if the A spot doesn't have an A in it, but instead it has a 4x squared? Well, that would mean that if I was expanding this, and instead of just writing A cubed, if there's a 4x squared there, I'm going to write a 4x squared cubed. Like the whole thing, 4x squared in parentheses right here, right there, cubed. Which means I'm going to have to go back and simplify when I'm done. And then if that B was something like 6z to the 5th, I'm not going to write B in all these spots. I'm going to write 60 to the 5th, 60 to the 5th squared, 60 to the 5th cubed, which means I'm going to have to go back and clean all that up before I finish. Now I'm still gonna have the 1, 3, 3, 1, or maybe the 1, 4, 6, 4, 1. I'm gonna have that in there, but you're gonna see by the time you clean it all up, you will not recognize those coefficients. You just won't in the end, because they're gonna be all simplified when these values are not just simple A's and B's. All right? So let me just walk you through that and see if you're with me. I'm gonna give you just some kind of random one. So what if you had, I don't know, how about 2x squared plus 3y, and we'll just raise this to the fourth. Now, what do you do when it's a simple a plus b to the fourth? Well, if you had an a plus b to the fourth, you're going to want to know how the a and the b work, right? A4, A3, B, A2, whatever, and how the b's work, no B1, B2, B3, B, but you also want the coefficients. So you want to go, if it's a 4, you want to go to the term, the row in the triangle that has the 4 as the second term, because those are the coefficients, right? But instead of writing A4, A3, A2, your A is really that. Instead of writing no B, 1B, 2B squared, B cubed, B to the fourth, your B is that. So when I go and start expanding this thing, I'm going to start with, and I'm going to leave some space, 1, leave a little space, 4, 6, 4, 1. So I'm going to use Pascal's triangle to give me my coefficients that I'm going to begin with, and then I'm going to think about the A's and the B's. Except that whole thing is my A, so I'm going to come right here and say A to what power? To the 4. And then A to the third. A squared. A to the first, no A. Are y'all with me on this? And I can put that plus in front of the 1 too. And then I'm going to come and I'm going to deal with the B term. The B term is all of that. So there was no B on this one, right? Then there was 1 B on this one, for the first. There were 2 B's on this one, 3 on this one, and then finally 4 on this one. Are y'all seeing this? But I can't stop here because we always clean everything up. So be really careful when you clean stuff up, okay? So if I have to raise all of that to the 4th, I have to raise 2 to the 4th, and at some point I am giving you a powers quiz. See, this is where your powers quiz really starts helping. Stinks not having you every day where I can just throw one out there, but anyway. So 2 to the 4th is 16, right? And then 16 times that 1 is 16. So I like to do the coefficients first. So 2 to the 4th, 16, 16 times 1. But what's x squared to the 4th? X to the 8th. A lot of people early in the year like this write x to the 6th. But remember, if I have a base with a power to another power, I multiply the powers. Don't add the powers. So power to a power, x to the 8th. And that's all I have from this term. Now what do I got going on coefficient-wise here? I have a 4 times a 2 cubed, which is an 8, times a 3. So I like to kind of organize the numbers so they make better sense in my head. Some of you go, oh, 24 times 4. That might be harder in your head than saying 12 times 8, I don't know, or 32 times 3. But look for ways you can do it without whipping your calculator out or having to scribble on the side. Sometimes you can pair group numbers together and it really makes your life better. But what does this give me?
96.
And then how many x's do we have? 6 x's, and how many y's? And then I'm over to this one, and this gives me a 6 and a 2 squared, which is a 4, and a 3 squared, which is a 9. All right? So when it comes to multiplying that, I don't know, some of you might be able to say 24 times 9 and figure that out pretty easily. Some of you might have better luck saying 36 times 6. You know, that might go, oh, 36 times 6, I remember 6 cubed was
216.
216, right? So whatever works for you, or maybe you have to write out to the side and do this out to the side. I'm just saying, you know, sometimes it's easier if you can think about how to group those numbers, you might not have to waste time doing this. And then how many x's? 4 and y's. Now, at this point, you probably see a pattern with the x's and y's. It may not be the original one where there's, you know, 4 x's, 3 x's, 2 x's, but look, 8, 6, 4, none, 1, 2. So you start seeing a pattern with the y's, so hopefully you won't make careless errors if you just kind of review that pattern at the end. But the coefficients, man, they don't look anything like Pascal's triangle anymore, do they? So again, Pascal's triangle is a way to keep from having to write this 4 times and FOIL all day long. Right? It's a way to kind of jump to your answer. But if you're wondering, are we going to do a lot of this? Probably not. But I'm going to show you something based on this problem that's going to hopefully help you, because in a second I'm going to be giving you stuff like this and saying, hey, what's the third term in the expansion? What's the fourth term in the expansion? And I want you to be able to get that fourth term without having to do all of this. And it's a pretty easy little method if you see a couple patterns. All right, then the last couple, what do we got? A 4 times a 2 times a 27. So I'd probably think of that as what, a 54 times 4. So what, 216? And I guess you could group a bunch and get 3 6s out of that also. And then x squared, y cubed, and then finally 3 to the 4th. 81. That's a pretty easy powers quiz problem. And that's my expansion. And you will probably have to do this once on a test. And on a test, I usually hover in the, you know, the 3, 4, 5 range so that it's not overwhelmingly brutal to do. All right? Now, one thing I want to point out, okay, and I'm going to point this out. I'm going to warn you ahead of time. I'm going to point this out, and if you just do the trick, you won't have issues. But if you do what I'm showing you and do the trick, you're going to make mistakes. So do one of the both, one or the other. But originally, I want to show you not a trick. Now, all of the rule we just came up with, all of Pascal's triangle, everything we've done has been based on a plus right there, right? So what happens if there's a minus? Well, if I'm going to apply this principle, if all of my rules are based on positives, then why don't I do this? When there's a minus, and this is not the trick, I'm going to think about it as plus a negative. Does that make sense? So now I can stick to my rules about keeping everything positive in the middle, but where does that negative show up? Here, 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 and there. But what happens when you simplify? Well, it's not affecting this term, but here I would have had what? 1 negative 3, which makes this what?
Whole thing negative.
The whole thing negative. Now here I would have had 2 negatives. 2 negatives does what? So that would not have changed this, would it? But here I would have had 3 negatives. 3 negatives would have made that a negative 27, right? Which would have made that a negative 216. And here 4 negatives would have stayed positive. Well, when I look at my final answer, I just see plus, minus, plus, minus, plus. So rather than do what I just did, now this is where people mess up, because I have people that do the trick and they throw the negative in there and everything ends up positive every time. And I'm like, what are you doing? The trick just says, hey, if you see that there's a minus in here, rather than putting the minus there and there and there, just say, oh yeah, when it's a minus, it's going to go plus, minus, plus, minus, plus, and then you don't have to worry about it anymore. You don't have to worry about including it. But don't do the trick and go plus, minus, plus, minus, plus, and put the negatives in there, or everything ends up positive again. Are you with me? So if it's positive, positive, it's all positive. But if it's positive, negative, it's going to alternate. Plus, minus, plus, minus, plus. Now, if you're thinking to yourself, well, what if it was negative, positive? Well, listen, you can come up with rules for all these, but if it was negative, positive, I might just turn it around and make it positive, negative, and just alternate the signs. And if they're both negative, Like if there were two negatives there, couldn't I factor the negative out? Like think about it. What if there were two negatives there? If there were two negatives, I could go, well, I'm going to factor out that negative 1, but how many times do I have to factor it out? This thing exists 4 times. So if I factored the negative out 4 times, well, in this case, the negative would just go away, and it would end up being all positive. But if it was an odd number, you'd end up with all negatives. But you know what I see for 28 years? I've seen nothing but both positives or positive negative. So honestly, that's what I'm going to test you on, and that's what you're probably going to see when it shows up. So, both positive, what are you doing? All positives. Negative in the middle, what are you doing? Plus, minus, alternating. And then you don't have to worry about putting negatives with each of these. You can just think about those as 2 separate terms, A minus B, and have a plan for that. Okay, let me show you one uglier one, and then we're going to use this uglier one to build our little proof. But before we do that, I want to talk about factorials. Y'all know what a factorial is?
Yeah.
All right, so help me out. What do you do with, and this is what I'm saying if you're not familiar with this. What does this mean, 5 factorial? 5 times 4 times 3 times 2 times 1? All right, and Tyree may have even had you memorize these. Did she make you go to a certain number? Which one, what was it? Really? Okay, I won't make you know those. I think it's great to know them through at least 5. 6 would be 720. I mean, you can know them higher than that, but a lot of times you're going to have a 10 factorial, 12 factorial, and you can't do a 12 factorial by going 6 factorial, 6 factorial. It doesn't work that way. Okay. Also, what would n factorial be? N times 1 less than it times n minus 2, all the way down to what? Till you eventually hit 1. You with me? What would something like 10 factorial over 7 factorial be?
3 factorial. Or no, sorry.
Yeah, you can't do that, right? But you can go, if I had written this out, which I'm not, I hope, and I hope you don't either. If you had written it out, what would you have noticed?
You can cancel out 6.
Right? So you end up with 10 times 9 times 8, which probably is not too tough to multiply. Right? And then what does this mean? 1 factorial? 1, and then what does this mean? And the definition of this is kind of weird, but I'll just trust me, 0 factorial means 1. And that has to do with combination and permutation definitions that use factorial that we can talk about later, but it's not really super important that you know the definition. All right, and then last thing, what would something like 12 factorial divided by 9 factorial, 3 factorial? What would you do to simplify something like that?
You would cross out 9 down, and then you could use the 3.
So if I expanded that from 12 to 1 and 9 to 1, everything but the what would cancel?
12, 11, and 10.
And then you'd still have the
3 and 2, and you could use that to simplify it.
and you don't have to put the 1. 3, 2, 1 is technically right, but the 1's not doing anything for you, right? And at that point you could say, well, that's 6, cancels with that 12, leaving me 2, and it shouldn't be too tough to get that. So if you can simplify this stuff like this, you're going to be in good shape. Y'all feel okay about it right now?
But what's
Okay.
the far right one? Could you do that one again?
This?
Yeah.
Okay, to really slow it down, this is what I would do. The 12 factorial is really this, right? 12, 11, 10, 9, 8, 7, blah, 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 blah. And then the 9 factorial would be the 9, 8, 7, 6, 5, all the blah, blah, blah. But you'd also have this 3, 2, 1 in there, right? Well, rather than write it all out, at some point you'll start going, oh yeah, all of that junk cancels, right? All of that cancels, and I'm only left with that over that.
Okay.
So try to be able to see that and go, okay, if I had it written out, don't go 3 into that, 3 times 3 into that, 4 times. It doesn't cancel that way. Just visualize these like that, and then remember what's left over, and then cancel. At that point, the factorial's gone, and you can cancel like normal. Okay, so I wanted to mention this, and now I want to mention this, Do you know, well, do I need to do that? I don't know that I need to do that. Okay, so I'm going to give you an ugly one, and then I'm going to show you a shortcut. So what if I had given you, let's go with 2x cubed minus 3y squared to the 10th. Ugh. All right? But here's my question. Determine the fourth term in the expansion. Now think about this for a second. How many terms are going to be in this expansion? That's what most people say, 10, but think about this. What if there was a 2 on it? If I square something, how many terms do I get? Actually get 3, right? And when you cube something, 1, 3, 3, 1, you get 4. So if there's a 10 there, how many terms are there actually? There's actually 11, aren't there? All right, now I want to show you something right here. Maybe I do need to show you this. Okay, so when you look at Pascal's triangle, let me make sure, ignore this right here, I'm going to just take a little sidebar. What am I doing? 1, 2, 3, 3. Like, why are these numbers getting weird? Okay, so that's Pascal's triangle, right? Now I want you to see something. This right here, make sure I get this right, hold on. Okay, this top number this number make sure I'm doing this right. This is this row, this is this row, this is yes, okay. This I'm not going to do all of these. I'm just going to go through this third one just to prove a point. And no, you don't have to know this if that's bothering you at this point. Okay, so let me clean this up a little bit for you. So this is how you would create Pascal's triangle. Pascal's triangle is nice and clever, but look at the math on this. What's 0 factorial?
1.
And those are 1s also? 1 divided by 1 times 1 is 1. What is 1 factorial?
1.
1, and that's a 1, and that's a 1 also? There's your 1. 1, 1, 1, there's your 1. What's 2 factorial? 2. But that 2 factorial is also 2, but that 0 factorial is 1. 2 divided by 2 times 1, still 1. But what is this? 2 divided by 1 times 1. And then this is back to 2 divided by 1 times 2. Now look at this one. 3 factorial is 6. 6 divided by 6 times 1. But look at this one. This is 6 divided by 2 times 1. This is 6 divided by 1 times 2. And this is 6 divided by 1 times 6. Are you seeing this? Now this is going to make sense in a second, but maybe not right this second. So if I was going to do the next row, the 1, 4, 6, 4 one, I would start with 4 factorial and go 4 factorial, 0 factorial, 4 factorial, 3 factorial, 1 factorial, 4 factorial, 2 factorial, 2 factorial, 4 factorial, 1 factorial, 3 factorial, and then I'd finish with 4 factorial, 0 factorial, 4 factorial. Now let me ask you a question. What does 4, 0, 3, 1, 2, 2, 1, 3, 0, 4 feel like to you? The exponents on my variables, right? That's a big deal for you to notice that. The exponents on the variables. Now I want to expand this thing, and I want you to realize, in fact, you know what? We're just going to go, we'll go through the 10th. But I'm going to use this process to find the numbers in the 10 row. So for the numbers, if it was being raised to the 4th power, I use 4, 4, 0. Because do the math on that. 1, that right there is what? 24 divided by 24 and 1. This is 24 divided by 6 and 1. There's my 4. This is 24 divided by 2 and 2. There's my 6. This is 24 divided by 1 and 6. There's my 4. Are you tracking with me? So on a 10 row, I'm not going to start with 4 factorial, 4 factorial, 0 factorial. What am I going to start with? 10 factorial, 0 factorial. That would be the number that stands for the 1 if I went all the way to the 10th. And then the next one would be what? It would be that, wouldn't it? And that is a massive number divided by another massive number, but what's left after I cancel everything? 10 over 1, that next number would be a 10 in this row. Now this next number is going to be massive. I say massive, much bigger than 10, because if you do the math on this, I'm left with 10 times 9, which is 90, divided by 2, which is 45. So it took, not massive, I guess, but it took a big jump, didn't it? And you're going to see them take more and more big jumps before they turn around and then head back and get small again. Now watch how this plays out. I'm going to do it the way I showed you to expand, although it's going to be a brutal. Anyway, let's do this. Let's do the 7th. And if I do the 7th, I don't have to do as long a triangle. And then I'm going to show you how this matches up. This thinking matches up with that 4th term and how you can jump to that 4th term. So I know I'm throwing a lot at you, and you're not going to have to remember much of this, but I wanted to show you a little bit of the why, and you're about to see this come together. So pretend you didn't just learn anything and tell me, if I needed Pascal's triangle to expand this, I could do it though, right? It's going to take me a second. And then finally, 1, 7, 21, 35, 35, 21, 7, 1. So those are the numbers that I would have used if I expanded the hard way, right? So here we go. Here's my expansion if I had to find all of them. And then in a second, we're going to go back and find the 1st, 2nd, 3rd, 4th term, the term that ends up being with that. So here's what I would have done the hard way. 1, something. 7, something. 21, something. 35, something. Yada, yada, yada. Are you with me on that? Yes or no? And then my A term is this, right? So I would have had that to the 7th, and then this to the nothing. And what do you do when it's minus?
Plus, minus, plus, minus.
Plus, minus, plus, minus. Plus, minus, plus, minus. Now, the next term would have this to the 6th, and that to the 1st. Right? The next term would have this to the 5th, and that to the 2nd. And then the term that I really want, this 4th term, would have this to the 4th, and that cubed. Now I want to show you something. Based on all that weird factorial junk that I showed you a second ago, do you remember how each row was created? This right here came from 7 factorial, 7 factorial, 0 factorial. And that 7 and that 0 match the exponents. 7 and nothing. That's why the other one wasn't there. This term right here comes from 7 factorial. Decrease that by 1, increase that one by 1. And this 6 and 1 match that. And if I do the math on this, I get 7. Now, if you're looking at this and going, what about the negative? Well, remember, technically there's a plus there and a minus there. Technically, right? If I didn't do my trick. So if you look at this, all I would have to do on this expansion, right, is get this number, copy this thing down, and take that 6 and 1 and put it there and there. That's my second term. Here, I could get that lead number, put a 7 on it because there's nothing to put with that 0. Okay, check this one out. This 21, what does it really come from? 7 factorial. If it's the third one over, it's gone 7, 6, 5, and 2. And sure enough, look, there's my 2x cubed to the 5th, and there technically is my negative 3y squared. Are you seeing this? The fourth term, that number, if I didn't want to do Pascal's triangle, I could say, well, 7 factorial, the fourth term over goes 7, 6, 5, 4. So 4 factorial, 3 factorial. Copy down the 2x cubed. Copy down the 3y squared, technically a negative 3y squared. Put that 4 and 3 there. My hope for you is that you don't do any of this when I ask you for the fourth term. And here's basically your binomial formula. Your binomial formula just says this. I'm going to write it out for you. And you're going to see it. If you remember this, then all this other stuff can fade off into the wasteland. The binomial formula says, if you have something like a plus b, and it may look a little different in your book, but whatever. The idea is the same. And I'm looking for, I'm going to call it the kth term. I'm just picking a letter like K. Okay? So if I'm looking for the 5th term, or the 4th term, or the 3rd term, or the 2nd term, I'm calling that. All right? All I have to do is this. Take whatever that n is, and put that on the top. And you can see that. Take that 7, put it on the top. Copy down the a and the b. Whatever it is. A, b. And then what do you notice about this? If I'm looking for the 4th term, what is that in relationship to the 4th term? 1 less. So if I'm looking for the kth term, then this is what? K minus 1. And whatever went there also went there. So you're also going to have a K minus 1, whatever that is here. And then what have you noticed about all the powers? They always add up to what? N. So when you think about it, whatever adds to this to give me n, that's what's going to go right there. Now that expression, when you look at the formula, is a little ugly. I'm trying to even see if I have that down. They do it a little bit differently, but that would be technically n minus k minus 1. So when I take that and add them together. Now your book thinks about it a little differently, but again, it's the same kind of formula, but I like the way I show it. We have a lot more success over the years with mine. So I don't really want you to memorize jack here. Don't. Okay? Here's what I want you to do on this. Literally, and it's this simple. You can forget all of this junk. When I say find the 4th term, find the middle term, find the last term, find the constant term, find the term with blah, 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 and I talk about a term, just start your problem out with 7 factorial on the top, copy down my a and my b. And since you don't know which place it's in, you don't know which positive or negative it's alternating, so just bring your negative over as well. Start every problem like that. And then, if I'm looking for the 4th term, what goes here? 1 less. 3. Good. And then 3 factorial there. And what adds to 3 to give me 7? 4. And 4 factorial. And all you have to do at this point is to multiply it out. So, what is 7 factorial over 4 factorial?
Where should I put 4? Like what?
Whatever adds to give me 7.
Oh.
So if that was 10, it would be 3 and 7. If it was 20, it'd be 3 and 17. It's just whatever's left over. Like, technically, that plus that gives me n.
Okay.
So 3, but again, that way you don't have to know the formula, because the formula's wordy. And they do it a little bit different. They say, looking for the k minus 1th term, and they put a k and an n minus k in there. But ignore all that. It's just an annoying formula, but it's really great if you just think about it this way. So all you have to do now is go, well, that's going to simplify to 7, 6, 5, because the 4, 3, 2, 1 is going to cancel. I also have this 3, 2, 1 on the bottom. I have 2 to the 4th, which is 16. I have x to the 12th. I have negative 3 cubed, which is a negative 27. And I have y squared cubed, which is a y to the 6th. And all of this is being added or multiplied? Multiplied. That's not subtraction, right? That's all multiplication. So at this point, just cancel jump. 2 cancels with the 16, leaves me an 8. 3 cancels with the negative 27, leaves me a negative 9. And all I got to do now is multiply that and that together, which granted is going to be a little annoying. Although you might be able to get somewhere with stuff like 5 times 8 is a 40. 40 times a 42 gives me a 168 with a 0. And then multiply that by a 9. What's 54, 61, 15, 120. Don't forget the negative. So negative 15, 120, if I haven't made a careless error, x to the 12th, y to the 6th. And you'll always end up with this neat, well, I try to make them a little bit more kind to you than this when it comes to the numbers, so because you won't have a calculator. Are y'all with me so far? Now, on your homework tonight, I'm going to do a couple other ones. If you get to stuff where you don't understand, that's okay, because we're going to come back and revisit it tomorrow. All right, so I'm going to do a few more of these practice problems tomorrow, really make sure you're in good shape. In fact, honestly, I might be even a little ahead of what I really want to do, but I'm going to talk about a couple other ones. Okay? So let me just throw something else at you. Hopefully you won't need that ugly formula, but in your head you'll know what to do. All right, so what if I gave you this? 2x cubed minus 5y to the 10th, and I said find the middle term. Well, this time I didn't tell you which term that was, did I? I didn't tell you it was the 4th, the 7th, the 6th. But think for a second. If that's to the 10th, how many terms do you have? 11. Wouldn't that be 5 on each side and 1 in the middle? So which term is that?
6.
So if I, and by the way, there's a trick for this too where you don't have to think as much. So the middle term, in this case, is actually the 6th term, isn't it? Right? So let's set it up. What do you do every time? 10 factorial, copy your A, copy your B. You can start every problem like that. And if I'm looking for the 6th, what do I put here? 5, one less, right? And then here, 5 factorial. And then, if I put a 5 there, how do I know what to put in this one? It's got to add to give me 10, so that's also a 5. What did you just notice? Middle terms, these are always going to be the same. So if you see that, I mean, think about it. What if this is a 12? If there's a 12, then what happens?
6 and 6.
Why? Because there's 13 terms. The middle term would be the 7th one, and if you're looking for the 7th, you put a 6. Are you following me?
Yep.
And they still end up matching. So when I see middle, I just go, oh, take the 12, split it, split it. Now the middle term problems are kind of tedious, because look at the math you get. 12, 11, 10, 9, 8, 7. Ugh. That's going to be a lot of canceling. 2 to the 6th is 64. Negative 5 to the 6th is 15, 625. See how it's great when you know your powers? X to the 18th, y to the 6th, and you're going to have to cancel a lot of stuff. There's a 8, there's a 3, I can cancel a 6, so I'm going to have to multiply all of that together and then put that on the end. I'm not going to do that to you on a test. But if you had a calculator at home, that's not a big deal, is it? Just pull it out, knock it out. Are you with me? That'd be a middle term. What if I said this? Drive time? 11:35? A little bit. What if I said, find the term that has a x to the 15th in it. Find the term with x to the 15th in it. If I'm finding a term, how do you begin every problem? 12 factorial, 2x cubed, negative 5y. Now, what would the power have to be to give you an x to the 15th? What would the power there have to be? 5? And if I put a 5 there, where else do I put it? Here? And if that's a 5, what does the other one have to be? 7? Can you do it? Math might get a little tedious, might need to pull out your calculator, but y'all kind of seeing this?
Yep.
So you can avoid the ugliness of that binomial expansion formula that's in your book, or the one that I use, which is a little uglier. You can ignore those if you understand the process. And we're going to go over a few more examples tomorrow and get you ready for that worksheet I have for you tomorrow. Yes?
So like the 2x to the third, like right?
Do you have the assignment?
Hold on one second. Yes, I do. Thank you for reminding me. Do what?
Like, so like the two numbers that like they're raising A and B to, they always are gonna be under the, like, literally A and always.
Yes, these will always match those.
Okay.
Yeah. Yeah, let me give you that assignment sheet. I forgot about that. I got it somewhere. If I ever forget that, remember I always have a copy. I always have a copy, digital copy on there too, but yeah, thanks for reminding me of that. Yeah. All right. Good luck tonight.